At Math 8, Unit 8, Lesson 6, two-way tables. This is actually the last lesson. We'll just do a quiz and some review before doing the test. The test is currently planned for early next week. Alright, first bit of review. Scatterplot diagrams are great for displaying and analyzing quantitative data. Now the word quantitative just means data that is numerical. So there's numbers involved. And let me display a couple of graphs that you should be familiar with. First, the scatter plot. Both the x-axis variable and the y-axis variable are quantitative here. I don't have them labeled with anything specific because I'm just talking about the fact that they are numbers. And we can look at positive, negative correlations, no correlation, that sort of thing. And also from your past, bar graphs. Bar graphs help analyze data when one variable is quantitative and one variable is qualitative. Now the word qualitative, that's categorical things. You're talking about, I guess, the quality of something, not the quantity. Because, you know, quantitative is talking about the quantity. And qualitative is talking about the quality. Now that doesn't necessarily mean quality is good, bad. It's just categorical things. So we've used bar graphs for this before. You could have several different groups, and that is a qualitative variable. And then a quantitative variable, maybe how many are in each group. For example, on this, Group A, Group B, and Group C, they're just three different categories in the population. And it looks like Group A there are 2, Group B there are 4, and Group C there's only 1. So we have done graphs in the past where one variable was qualitative, categorical, and the other was quantitative, numerical. So how do you analyze bivariate data that is qualitative, where both variables are categories? Well, let's think. Here's a couple of examples you might need to do. You might want to compare hair color to gender. There's a list of hair colors that are possible. A couple of genders. You could compare grade level to cell phone ownership. And there you'd have some different grade levels and some cell phone ownership. As we get into this, though, we're going to be using what are called two-way frequency tables. Now, on a two-way frequency table, you're going to have qualitative data on both the x-axis and on the y-axis. It's not going to end up looking like this, though. We actually flip the x-axis up to the top, and it's like we're using quadrant 4 of the coordinate plane. And our x-axis qualitative variables are listed, and our y-axis qualitative variables are listed. And then we get this array of categories. There will be a number in each of these because frequency. There's the number that are in Group A and Group B, and it'll be some number. And these will just have various numbers in them. Something like that. And we actually look for associations and trends here. For example, it's quite likely for Group C and Group B Group C from the X variable and Group B from the Y variable to coincide. Alright, so two-way frequency table below shows the favorite leisure activities for 50 adults, 20 men and 30 women using frequency counts. Okay, this is exactly what a two-way frequency table will look like. Now, your x-axis is, if it's properly labeled, it will be favorite sport. And y-axis would be gender or sex. And There's also these additional, they're not really categories that were added. They're the total column and the total row. Some things you should notice here. The number that like dance, 16 are women, 2 are men. If you total that together, that's 18 total that like dance. So this 16 means 16 women like dance, 2 men like dance, 18 total like dance. 6 women chose sports, 10 men chose sports, 16 total chose sports. 8 women chose movies, 8 men chose movies, and 16 total chose movies. 30 women were surveyed, 20 men were surveyed, and 50 total were surveyed. Okay, there are 4 different types of tables you'll need to be familiar with. We're going to use this same data to create the other 3 types of tables. The second is called a relative frequency table. Now, reminder of what relative frequency means. You used the term relative frequency back in 7th grade when you were doing probability and statistics. It is the frequency relative to everything else. So it'll be the number of something compared to the total. That's what relative frequency is. So to create this table, the previous table, we had 50 down here in the corner. Every number in the table gets divided by 50. So this is divided by 50, divided by 50. Everything's done relative to the total. So everything's divided by 50. And that gives you these numbers. The two-way frequency table below shows the favorite leisure activities of 50 adults, 20 men and 30 women, using relative frequencies. Relative frequencies divide by the total. Generally, relative frequencies are written as a decimal or a percentage. It is the ratio of the actual number of favorable events to the total possible number of events, often taken as an estimate of probability. You can use the relative frequency to determine how often a value may occur in the future. Yeah, this definitely ties into probability from 7th grade. These would be the experimental probabilities. Anyway, every number here has been divided by the 50, so that's showing 100%, but it's actually written as a decimal, it's just 1. This one right here, 12% of those surveyed were women that like sports. 20% of those surveyed were men that like sports. Notice that I'm saying of those surveyed. That's because the total is comparing to those surveyed. Now there are 2 more types of tables. There is the relative frequency by row and relative frequency by column. The thing you should notice, when it's a relative frequency by row, the total column has 100% in all of them at the end of each row. And the reason for that is it's relative by row. Let me go back to the original table and explain where these values come from. The relative by row, you're going to take the end of the row and treat it as the total. It's going to be relative to that total. So everything in this row is compared to the 30 at the end of the row. Everything in this row gets compared to the 20 at the end of the row. I guess these need to be divided as well. And in the total row, everything here needs to be divided by 50. Now this last row will look exactly the same as it did in the relative frequency table. So after dividing everything out, when I divided this whole row by 30, I get 0.53, that got rounded, 0.20 and 0.27. In the second row, I divided everything by 20, giving this as 100%. We got 10% of men that like dance. Yeah, since we use the total number of men as the comparison, we can actually say this is 10% of men like dance, 50% of men like sports, 40% of men chose movies. 53% of women chose dance, 20% of women chose sports, and 27% of women chose movies. Now the last one has relative frequency by column. And when you do relative frequency by column, when we go back to the original one, you look at the end of the column and you use that to calculate totals. So the total that like dance were 18, so everything will get divided by 18 here. The total that like sports was 16, so everything gets divided by 16. The total that like movies was 16. And then this last one, everything just gets divided by 50, including the bottom rows. I forgot to put that we were dividing on the bottom rows. So when that all gets divided out, everything is compared to the column total. So on this, the way you would say it, 89% of those that like dance were women. 11% of those who chose dance were men. 38% of those who chose sports were women. 62% of those who chose sports were men. 50% of those who chose movies were women. 50% of those who chose movies were men. 60% of those surveyed were women. 40% of those surveyed were men. And I just realized I didn't talk about the totals up here. This one right here would mean 36% of those surveyed liked dance, 32% of those surveyed chose sports, and 32% of those surveyed chose movies. Okay, let's look at an example here. This is a type of problem you will need to know how to do. So a gym has 69 members. 38 of these members are boys. So you can see boys total is 38. So that's already put in the table. There are 19 members who are girls under 15. Girls under 15, 19, there it is right in the table already. Sometimes you'll have to put these in the table. There are 23 members who are boys and over 15. There we go. Complete the table, work out how many members of the gym are girls 15 years old or over. All right. One thing that I pointed out a few minutes ago, these will add across and they will add down. So this number plus 23 is 38. It would have to be 15. Okay, that gives me this. I can add down 15 and 19 is 34. 34 plus blank is 69. That would have to be 35. Now I can do some additional ones here. 23 plus blank is 35. That would have to be 12. 38 plus blank is 69. That'd be 31. Okay, just double checking one thing. 19 plus 12 is 31. That is true. So I have everything filled in now. Probably don't need all those circles. So let me clean this up a little bit. That was 15 and 34. 12 and 35. This last one was 31. Okay, work out how many members of the gym are girls 15 years old or over. So right now we're interested in looking at the number of girls over 15. That comes together with this number here. There are 12. There are 12 girls over 15. Okay, next. You randomly survey students in a cafeteria about their plans for a football game and a school dance. The two-way table shows your results. How many students will attend the dance but not the football game? Okay, attending the dance, not attending the football game. Those come together to make this joint frequency of 5. So there are 5. B, find and interpret the marginal frequencies in the survey. Okay, marginal frequencies, we'll go over this in a couple of minutes, but marginal frequencies are the totals. So the total that will attend the football game, we would add these together and get 51. The total that will not attend the football game, we add these together and we get 25. It does say to interpret them. We'll get back to it in a moment. If we add these, 40. If we add these, 36. If we add down, we get 76. So we're going to interpret what each of these numbers mean. First, 51. 51 are going to attend football game. 25. 25 do not attend the football game. 40. 40 attend dance. And 36 do not attend dance. And the last one here is 76. 76 students were surveyed. Yeah, that bottom corner, when it's just a frequency table, tells you how many people were surveyed in total. Okay, this data is a year old. It's as of March 30th of last year, 2019. I don't have the current data. Couldn't get in and meet with the secretary to get that. Anyway, this is RJHS enrollment on the computer, and every student has a gender specified and a grade level specified in the data records. So these tables can be put together. Now, for you being 8th graders, you would be represented, if you were at Roosevelt Junior High last year, in the 7th grade section. Okay, first, just the basic relative frequency table, just the frequency table itself. These are the numbers in each grade level. You can see that 277 6th graders, 257 7th graders, which would be you guys now this year, 269 8th graders. So it was fairly evenly split last year. This year we've got a lot more 6th graders than the other groups. There were over 300. I think actually these have increased as well. But that's your frequency table. In here you can look and quickly get information like how many 7th grade girls, there were 135. How many 8th grade boys, there were 120. In fact, the 8th grade last year was heavy on number of girls. There were a larger percentage of girls. In fact, we'll look at some of these other tables to make those comparisons. The relative frequency table makes a comparison to the total. This gives you the percents in each joint frequency category. Of the students at the school, that would be 100%, 15.7% were 6th grade boys. 18.6% were 8th grade girls. 18.8% were 6th grade girls, which that's actually the most common joint frequency out of the whole thing. And if you look back here, 151 was the biggest number out of all of the joint frequencies. Okay, we move on. Let's look at the relative by row and by column. Okay, the relative by row are making comparisons in the rows. So what these numbers mean. The 6th grade was 45.5% boy and 54.5% girl. The 7th grade, since I'm making the comparison across, 47.5% boy, 52.5% girl. 8th grade, 44.6% boy, 55.4% girl. And total across the whole school, 45.8% boy, 54.2% girl. Which means that at our school, girl students are outnumbering boy students by a significant number. If you look up here, we're comparing 368 to 435, which in the average population, boys do outnumber girls slightly, probably around 50.5 to 51%. But not at our school. At our school, it looks like currently girls are outnumbering boys. Well, at least last year they were. Okay, the relative frequency by column. This is where the comparisons are made in the columns. So what these numbers mean. 34.2% of boys were in 6th grade. 33.2% of boys were in 7th grade, and 32.6% of boys were in 8th grade. For the girls, 34.7% of the girls were in 6th grade, 31% of the girls were in 7th grade, and 34.3% of the girls were in 8th grade. And it looks like school-wide, 34.5% of students are 6th graders, 32% were 7th graders, and 33.5% 8th graders. Remember, this is last year's data, so it's a little different. This year, this is not 803, it's closer to 900. 904, 897, somewhere close to 900 for this year. So the numbers would change. All right. These are the notes. I'll just read through them. I can represent bivariate data in a two-way table and use two-way tables to solve problems. First, a two-way frequency table displays data from two categorical variables collected from the same source. It may include totals. Here is a two-way table that compares student study efforts compared to test results. So, and the meanings of these are given. We've got the grade that they got, they either passed or failed. We've got students that studied or did not study, and of course the totals. And you can see the numbers in there. Okay, couple of vocabulary words. A joint frequency. I've already used this word a couple of times. A joint frequency tells how many things for each pairing of categories. For example, 21 is the joint frequency that shows the number of students who studied and passed the test. There are three other joint frequencies, namely 2, 1, and 6. The sums of each row and column are called the marginal frequencies. These would be the marginal frequencies. Let's actually do it in a little bit different color. The marginal frequencies are these numbers. I guess it might include this, although I just call that the total number surveyed. Each marginal frequency is interpreted in the table above. 22 students studied, 8 students did not study, 23 students passed, 7 students failed, and 30 students were surveyed. In a two-way frequency tables, rows add across and columns add down. There are three other types of two-way tables. Using the same data as above, these would be the relative frequency tables. All joint frequencies and marginal frequencies are relative to the overall total. Each relative frequency could be represented as a decimal or a percentage. And keep in mind, all entries are divided by the overall total here. Okay, in relative frequency by rows. All joint frequencies, that's these things, are relative to the marginal frequency at the end of a row. Therefore, all rows will add across, but the columns will not add down. All entries are divided by the total at the end of the row. Relative by columns, all joint frequencies, that's the 4 here in the middle, are relative to the marginal frequency at the end of each column. Therefore, all columns add down, but the rows do not add across. All entries are divided by the total at the end of the column. Okay, let's look at some examples. On this one, we're going to fill in the frequency table with the given information. Of the students that like math, 50% are girls. Now, we don't really have a lot of information here. We just know it's half and half here. We're not told the total number of students that like math. 9 students like English. All right, students, that's including both boy and girl. Twice as many girls like English as boys. Okay, if we want twice as many girls as boys, they've got to add up to 9. 5 plus 4, 5's not twice as much as 4. Let's try 6, 6 and 3. 6 is twice as big as 3, so it will be 6 and 3 here, for there to be twice as many girls as boys. We've used those two, so I'm going to go ahead and cross them out. 5 of the 6 that like science are boys. Okay, we've got 6 that like science, of which 5 are boys. I guess the other one would be a girl. 1/4 of the 8 students that like history are boys. Okay, there's history, 8 total students. And 1/4 of 8, 1/4 times 8 is 2. That would leave 6 girls liking history. There are 31 students. All right, that would fill in this number here. Of the students like math, 50% are girls, so we'll have to use that one in just a moment. First, we need to do some figuring here. 31 is this number plus 9 plus 6 plus 8. Well, 9, 6, and 8 would add up to 23. So this is going to have to be 8 students that like math. And if it's half girl, half boy, they're 4 each. Now we can total these down. 4 and 3, 7, and 5 is 12, 14 here for boys. And this should come out 17, but we'll see. 6 and 4 is 10, 1 is 11, 6 is 17. We get 17 girls, total of 31. Okay, it's all filled out. You randomly survey students between the ages of 12 and 17 about whether they ride the bus to school. The results are shown in the tally sheets. Make a two-way table that includes the marginal frequencies. Okay, there are 2 categories. They're for the ages and for the bus, whether or not they ride it. Use the tally sheets to calculate each joint frequency, then add to find each marginal frequency. All right, on this, these tally sheets are nice. 12 to 13-year-olds who ride the bus, it looks like 5, 10, 15, 24, 5, 10, 12, 5, 10, 14. Maybe that's a 14, might be 13. Anyway, just doing the rest of them here real quick. Okay, we first come up with our frequency, or our categories. The category of age, there are 3 different categories in age: 12 to 13-year-olds, 14 to 15, and 16 to 17. In student, they either ride the bus or they don't. Okay, and then we fill in the rest of the table. So along the x-axis we chose age, and on the y-axis we chose whether they ride the bus or not. Okay, as we look at the ones who ride the bus, that's the first tally sheet here. 24 were 12 to 13-year-olds, 12 are 14, 15-year-olds, and 14 of them are 16, 17-year-olds. Of those that don't ride the bus, looking at the bottom tally sheet, it's 16, 12 to 13-year-olds, 13, 14 to 15-year-olds, and 21, 16 to 17-year-olds. And then we go ahead and do our adding up. If we add down, we'll get these totals here: 40, 25, and 35. If we add across the rows, we'll get these totals, both of them at 50. And the total in the bottom corner is 100. All right. And that's pretty much how you make these. We'll go into a little bit more detail with the next example. This one was already here, and you see that I was able to just click and make things disappear to have it show up. But you will be needing to create one from scratch, and that's what we're going to do here. You randomly survey students at a school about whether they buy a school lunch or pack a lunch. The results are shown. Make a two-way table that includes the marginal frequency. So we want the totals. All right. So we have, it looks like grade and lunch. So let's make grade along our x-axis. And we have 6th grade, 7th grade, and 8th grade. On our y-axis, we're going to do lunch. And with lunch, they're either going to pack a lunch or buy school lunch. Okay, filling in a table here. We do need to have the totals. So I should have included those. It's okay, we'll just add them in now. A little bit of a pun for you, adding the totals. All right. Okay, now we go through the data and figure this out. It looks like 6th grade students, 11 of them pack a lunch, 9 of them buy school lunch. 7th graders, 23 pack a lunch, 27 buy school lunch. 8th grade, 16 pack a lunch, 14 buy school lunch. And now we've just got to do the totals. Sixth graders, we've got 20, 9 plus 11, 23 plus 27 is 50, and 14 and 16 is 30. For some reason, they surveyed a lot more 7th grade students than the others, as many 7th grade students as total for 6th and 8th. Maybe the survey was conducted by a 7th grade student. Anyway, doing the totals across, 11 and 23 make 34, and 16 more make 50. 9 and 27 make 36, and 14 more make 50. Looks like 100 students were surveyed. For each grade level, what percent of students in the survey pack a lunch? Buy a lunch. Organize the results in a two-way table. Explain what the entries mean. Since we are doing percentages of the grade level, this would be perfect for a two-way relative frequency by column. So going to recreate this as a relative frequency by column. We've got pack lunch and school lunch, 6th grade, 7th grade, and 8th grade. The totals, of course, are going to be 100% on all of these. Oops, wrote that wrong. 100%, 100%. Okay, of those that pack a lunch, it would be 11 out of 20, which comes out to be 55%, and 9 is 45%. For 7th graders, 23 out of 50 is 46%, and 27 out of 50 is 54%. For 8th graders, 16 out of 30 is 53%, 53.3 repeating percent, and that'll give us 47% for those who pack a school lunch. So those are all of the relative frequencies by column for this situation. What else we got? Does the table from part B show a relationship between grade level and lunch choice? Does it show the relationship between grade level and lunch choice? No, it doesn't. It shows the, well, actually, yeah. Let me reread that because we got to be specific here. Does the table in part B show a relationship between grade level and lunch choice? Okay, looking across the different grade levels, is there anything we can say about what each grade level seems to prefer? I really don't think so here because all of them are pretty close to 50%. In general, it looks like 6th and 8th graders tend to pack lunch a little bit more than 7th graders, but there's not a whole lot you can say here. Okay, all right, here's your assignment. On this, number 1, you're just going to be filling in those 4 tables. Number 2 asks questions about data in these tables. You may have to do some calculations. Please read the questions carefully. It makes a difference if they say of the total or of boys. It depends on what you'll need to divide by. Number 2, we've got a scatter plot question. Number 4, or that's number 3. Number 4, you're going to make the linear model for that scatter plot. Number 5, solve the system by graphing. You'll just graph both of those. Number 6, find the volume of a basketball. Remember, a basketball is a sphere. That's V equals 4/3 pi r cubed. Number 7, this one you will have to design a two-way table to answer the question. Part B gives you all of the data that you'll need to plug in. And then part C is an opinion question. Why is this type of table a good way to show this sort of information? Actually, it's an opinion question where most people will end up having the opinion. Number 8, you're going to complete the table and then answer 4 questions about it. Please read them carefully. What is it asking? Is it asking of students, of female students, of those that ride the bus? It tells you what you'll need to divide by. Thanks for watching.